Hello everyone, welcome to this session. We're discussing about the formula bonding and the nomenclature. So far in our past videos, we've seen the various binary compounds, how you can write them. So today let's see the nomenclature of the inorganic compounds. So here we're going to see basically we'll start with the concept of nomenclature. The term nomenclature, it refers to the system of naming. So when you're talking about the nomenclature of the inorganic compounds, here we're talking about the system of naming of the inorganic compounds. So the system of naming in use of these inorganic compounds as just recommended by the IUPAC, that is the International Unit of Pure and Applied Chemistry. So the modern system of naming, what it does is that it reveals the type of elements present in a given compound. The odd or the trivial names have been dropped out. So that has to be noted within the modern system of naming or the nomenclature. Moving on, let's see the nomenclature of these inorganic compounds. So some common or important compounds, they have historical names that they do not seem to fit in the system of this naming, which we've said before, the IUPAC. So for example, the water, ammonium, methane, and some of the mineral acids such as the sulfuric acid, nitric acid, and hydrochloric acid. Also, some of the organic acids such as the ethanoic acid are also included in this kind of a group. Now, all these names are trivial, but they have been adopted in the modern nomenclature. Now, if these exceptions they are omitted for the naming of such compounds, there are basic generalizations that are useful and they can be considered. So here we're going to see the various like some generalized observations or rules that are useful for the naming of the compounds. The first one is that if there is a metal within the compound, it must be named first. So this is the first generalized consideration for the naming. So if there is a metal within the compound, it must be named first. In this case, ammonium ion, take an example, is regarded as if it were a metal within the compounds it occurs, such as the ammonium nitrate and the ammonium chloride. The second one that for elements with the variable valence, such as the iron and the lead, the Roman numerals are included in the name to indicate the valence of the metal or the ion which is present. For example, the iron 3 chloride contains the iron 3 ions, while the iron 2 chloride contains the iron 2 ions. The same case may be applied to the iron 2, to the lead 2 and the lead 4 compounds, and so on and so on, which they have these variable valences. The third one that the compounds containing the two elements only, we are talking about the binary compounds, they have names ending in ID. For example, the sodium chloride ID is there, the calcium bromide ID is there, magnesium nitrite is also there, like kind of ID there, etc., etc. So all these compounds, they containing the two elements here, talking about the binary compounds, they've just this kind of names ending with ID and IT, which can look identical to the ID thing. The important exception for this is the hydroxides, which contains the hydroxide ion. The fourth consideration is that the compounds containing the polyatomic ion, usually containing the oxygen, they have names that end with 8. For example, the calcium carbonate, there's 8 there. Potassium nitrate, there's 8 there. Magnesium sulfate, there's 8 there. Sodium ethanoate, there's 8 there, etc., etc. All these compounds which they contain these polyatomic atomic ions, they have this kind of a naming system. The other consideration that the names of some compounds, they use a prefix to tell you the number of that particular atom in the molecule. So this is very useful if the two elements form more than one compound. For example, Here, talking about the example, maybe carbon monoxide. As you can see there, carbon dioxide, also nitrogen dioxide. You can see the naming there, the prefix are there just to show the kind of the compound we are talking about due to the number of particular atom within the molecule. More example, the nitrogen dioxide di there, it means there are two. The nitrogen tetraoxide, there tetra is simply referring to four. The sulfur dioxide di for two, sulfur trioxide for three. So all these prefixes are there just to tell the number of particular atoms that are within the molecule. So for the following prefixes, uh, they indicated the number of atoms in cases like this. Take as follows: the mono can be used for one, di for two, tri for three, tetra for four, pent for five, hex for six, hept for seven, oct for eight, non for nine, and dec for 10. So all these prefixes are there just for the naming of such compounds. So obviously, guys, thank you for listening. So far, we've seen the nomenclature of the various compounds. Here, we are talking about the naming system of the various compounds. Thank you.